Today this is section 7.6, and we are learning how to write an equation given a point and a slope or given 2 points. Okay? This is section 7.6 of the green book. So, meaning I'm going to be able to write an equation that looks something like this, given a point and a slope, or given 2 points. Now, this equation has nothing to do. I just made things up, right? Do you understand? We're going to start with either a point and the slope and write that equation, or we're going to start with 2 points and be able to write that equation. That is our objective today. Okay? All right. Let's start with a little warm-up. How would I write the equation for this line? What do we need? Yes?
Rise over run.
Okay, and what else? Yep. We need a y-intercept, and we need, what is the rise over run? What is that called? Slope. So we need a slope, and we need what else? A y-intercept. So what is my y-intercept? Ethan?
What's it called? 3.
Is a 3. Right here, I count 1, 2, 3 up, and my rise over run, or my slope is, Jonah?
It'd be 2 over 1.
2 over 1. So my b is 3 and my slope is 2 over 1. And and now we can write the equation of a line in y equals mx plus b slope-intercept form. What would the equation look like? Okay, Oliver?
Y equals 2x plus 3.
Y equals 2x plus 3. Good. Y equals 2x plus 3. I'd like you to pause the recording and do the next one. Go. Okay, Riley, what's my M? Or what's my B?
The slope is 1/3.
My M is 1/3. And my B?
-4.
And so what is the equation?
Y equals 1/3 x minus 4.
Perfect. So does everybody understand what it means to write the equation?
Wait, that doesn't make sense. It's a minus.
Yeah, it's a -4. There we go.
It's a -1/3. Yeah, it's -1/3. Right now?
Oh, you're right. Sorry. Okay, because I'm going down 1, that's -1, and +1, 2, 3. So -1 over +3 is a negative. Does everybody understand what it means to write the equation of a line?
Yes.
Okay, the equation of a line will have a number for the slope and a number for the y-intercept. So, we're going to use one of my favorite formulas. It's called point slope. Okay, most underused formulas, but I really like it because it allows you to be a little bit robotic and kind of get to where you need to be without having to start and stop. We use point slope. Well, here is point slope. And we're going to take a little bit of a side step. The point slope form is y minus y1 equals m times x minus x1. What does that look like to you? What does it look like to you? Okay, Ethan?
It kind of looks like that, like when you're finding out the algebraic slope, you do y2 over y1, so it's kind of like that. You give x.
That's exactly right. It looks like the slope formula. Not slope-intercept, but slope formula. And the slope formula is such. It's m equals y2 minus y1 over x2 minus x1. So let's talk about where point slope came from. Because for me to memorize, I need to know why. As opposed to somebody saying you just have to memorize this. So, how would I get rid of those x's? Get them out of the denominator? How are we getting them out of the denominator? Oh, how would I get the x's out of the denominator? Go, Maxime.
You have to multiply the denominator by both sides.
Both sides by the denominator, so multiply by x2 minus x1, multiply by x2 minus x1, and sure enough, what do we have is x2 minus x1 times the m equals y2 minus y1. Well, what happens if I just switch everything on this side to this side, and everything here I get y2 minus y1 equals the slope m times the quantity of x2 minus x1. Now, how is this different to point slope? What's different about it? Adam? There's no 2. There's not. And what does y2, x2 represent? Specifically, what does x2, y2 represent? Logan?
2 points that you...
No, not 2 points. The second point. It represents a second point. So for point slope, we don't need 2 points. We only need 1 point. We use our generic y and our x. We find our slope. And so this is how we got point slope. So let's go use our point slope formula. A question might read something like this. Write the equation of a line in point slope form that passes through a point 2, 5 with a slope of -3. So the first thing you're going to do is write the point slope formula. Why? Because they gave us a point and a slope. Why do I use point slope? Because they gave me a point and a slope. So what is the point slope form of a line? Go, Gideon.
The point slope form of a line?
Give me the formula.
Oh, y minus y1 is m times x minus x1.
M times the quantity of x minus x1. Okay, so now all I have to do is remember this 2, 5, this is the first point. It's x1, y1. So I substitute that in. So it's going to read from left to right. Y minus what? Y minus the 5 equals, what is my m? Equals -3 times the quantity of? Good. And there we have it. They asked me, number one, how to write the equation of a line. And then how did they want it? They want it in point slope. So I am done. That's all there is to it. Given a point and a slope, can you write it in point slope form? Okay? Write the equation in point slope form. Questions? All right. Now, yes. No, not yet. Not in this question because they said they want it in point slope. At this point, there's no reducing. So, basically, the same way I have multiple names. My name's Michelle. My name's Yamasaki. Some people call me Carson if you knew me from 20, 30 years ago. And some people call me Mom. Other people call me Teacher. I'm the same person. The same way I'm the same person, an equation can be written in different ways. So, in standard form, the equation has the x and y on the same side of the equal sign. You need to write this. In slope-intercept form, y equals mx plus b, the y is alone. And point slope form, well, we know what that looks like. You should be writing this, not staring at it. Okay? So standard form of an equation is when x and y is on the same side of the equal sign. Okay? Slope-intercept is when y is alone. Get the y alone in the equation, you're in slope-intercept. Point-slope. I use this if somebody gives me a point and a slope. But these are the same equation. Okay? These are the same equation. Pause the recording if you need to finish taking notes. So the question is, are we ever going to have to solve this? I'm going to show you how these three are related. To solve this is not to say there are infinite solutions. Remember, when you have two variables, there are infinite solutions. Knock it off. Okay? All right, so here we go. Let's actually use this. Okay, write an equation in slope-intercept form that passes through -2, 6 with a slope of 3. Now here they didn't say use point slope, but did they give me a point? Did they give me a slope? M equals 3. We have a point. Okay, so I can use my point slope. They didn't say use point slope, but I'm going to use it because I have a point and a slope. So I start with the formula. You always start with it. Now let me actually start it up here. So I've got y minus y1 equals m times x minus x1. Okay? So what would I substitute in? Finnegan?
Y minus 6.
Y minus 6 equals
3
times the quantity
of x plus 2.
x minus -2. We can turn that into a plus. Okay, right here, y minus 6 equals 3 times the quantity of x plus 2. This is point slope form of the equation. Do they want it in point slope? No, they're saying write the equation, that's part 1, in slope-intercept form. Slope-intercept form means what? What? Get the y alone. So we're going to keep going. I got to get my y alone. So now I'm going to distribute. Simplify and distribute. So I get y minus 6 equals 3x plus 6. Okay? I'm going to add 6 to both sides. And now I have y equals 3x plus 12. Okay? What are we in? What's that called? This is the slope-intercept form. Now I told you that there were 3 forms of an equation. Yes.
So for the third part, distributed and it was positive 6, and then you add from ICU.
From the other side, right. Okay. So now the third form of an equation is standard form. Standard form, right? So I am going to, let's see, standard form. To get this into standard form, x and y are on the same side. What am I going to do, Karen? Subtract the 3x. Subtract the 3x. I end up with negative 3x plus y equals 12. Now, my x and y are on the same side. Okay? The other thing about standard form is the a, b, and c, the integers have to be integers, not fractions. But negatives are okay. So it's negative 3x This is standard form. Now, I should have made a space. This means it's just like I have different names. This is the same equation. Y minus 6 equals 3 times the quantity of x plus 2 is equivalent to y equals 3x plus 12, which is equivalent to negative 3x plus y equals 12. It's like calling me Michelle. It's like calling me Yamasaki. It's like calling me teacher. 3 different ways to write the same equation. Do you understand what I'm talking about? Now, in these directions, how do they want it? So you're going to stop here. Do you understand? You're not doing that blue part. I just wanted to show you how all 3 were related. Does that make sense? Okay, questions there? All right, if they don't tell you how they want it with the y alone. It is assumed that if they don't mention it, that they want y alone. Okay? All right, I'd like you to pause the recording and you try the next one on your own. Alice, what?
Would I go? Or?
No, I want you to tell me what to do. Start with?
So first you write the equation.
Which is?
Which is y minus y1 equals m parentheses x minus x.
M times the quantity. Say m times the quantity.
M times the quantity
Of. Keep going.
M times the quantity of
X. We don't say m parentheses. We say m times the quantity.
M times the quantity of x
Mi-
minus x1.
Good. Now, what am I substituting?
Y plus 1.
Y minus negative 1. I like to write both negatives just to record what was originally given. Okay.
Y minus negative 1
Good.
equals 3 over 5
Shh. Uh-huh.
times the quantity of x minus 5.
Perfect. Now, I'm going to really write this. I would then just, we can simplify that to y plus 1. I would go right to y, whoops. Y plus 1 equals, I start distributing right away, 3/5 x. And now, notice, this is 5 over 1, so when I distribute, that'll cross cancel. We'll be left with minus 3. What do I do next, Oliver?
You subtract 1.
Subtracting 1, and we're left with y equals 3/5 x. Negative 3 minus 1 is negative 4. And I stop because now I'm in slope-intercept form. Okay, questions? Okay, Amani, question? Okay. Now you'll notice in my PowerPoint I did that in 2 steps. You don't have to. All right. Let's take a sidebar. So let's look at the second part of the homework. They're going to give you 2 points. -6, 1, and 2, 3. Now I just taught you how to use point slope. When do we use point slope? When we're given what? Everybody. A point and a slope. Everybody. A point and a slope. Okay? Well, what am I missing here? A slope. I have a point. I have 2 points. So I don't have the slope, but I have the ability to find the slope. Given 2 points, why do I have the ability to find the slope? Adam.
So with 2 points, then you can use the x minus x, or x2 minus x1.
We call that the slope formula. Okay? And the slope formula starts with a... No, it does not start with y2. Go.
M equals y2 minus
M
y1
equals y2 minus y1 over x2 minus x1. Now I'm going to just remind you, this is x1, y1, x2, y2, and so we're basically subtracting that, 3 minus 1, and now I've got 2 minus negative 6 over 2 minus negative 6, and that simplifies to 3 minus 1 is 2, and this is over 8. Does that simplify? 1/4. So my slope is 1/4. I'm going to use that. M equals 1/4. And what else do I need? Yep.
You need the point.
I need a point. Now, I get to choose my point. I choose which point? Okay. I'm going to choose 2, 3 because there's no negatives there. And now, I've got a slope and a point, so what am I going to use? Point slope formula. What is it?
Y minus y1 equals m times the
Quantity of x minus x1.
And you write this every time because your head's going to be spinning the night before the quiz, trying to stare at formulas and try and learn it the night before. So every homework problem, you're starting with this. Okay, now I'm substituting in. I've got y minus, I've got a 3 equals 1/4 times x minus 2. Right, there's your x1, y1. You should be writing this, not staring and stretching. Okay, I'm going to simplify that. Y minus 3 equals 1/4 x. And now I'm distributing here. When I distribute here, that's like 2 over 1. 2 goes once, twice. 1/2 times 1 over 1 is minus 1 over 2. Okay, questions? Yes.
Just to clear it up, so we could have chosen negative 16.
Yeah, let's finish this. Now, look very closely. Okay? You got to do some fraction work. I'm adding 3. Can you stop? I'm adding 3, and over here, when I add, I have to have a common denominator. I have to have a common denominator. So what's the common denominator? What's the common denominator, Finnegan?
6.
No, that's not the common denominator. Let's go, Megan. 2. So what over 2 equals 3? Everybody.
6.
Okay, so it's positive 6 over 2. You can just write it like that. I'm adding 3 to both sides. Just the way I wrote it on the right side looked a little different. It's just another name for 3. So now you see my 3's cancel. I'm left with a y equals 1/4 x. Positive 6, negative 1 make what?
Positive 5 over 2.
5 over 2. And I am done. Now, somebody said to me, what if I use the other point? It doesn't matter which point, because the point you choose, either it's one down here on the line or it's up here. Do you understand? So I can still, y minus y1 equals m times x minus x1. Y minus 1 equals 1/4 times, put your hand down, x minus negative 6. Y minus 1 equals, let's make that a positive, 1/4 x plus, I can cross cancel, 2 goes into that 2 times and 3 times, so that'll be 3 over 2, positive 3 over 2. Now I have to add 1. So I'm going to add 2 over 2. And I end up with y equals 1/4 x plus 5 over 2. Same thing, right? Do you have to do both points?
No.
No, you just choose one. I always choose the one with less negatives. Sometimes you can't get away from the negatives. So I probably would have stopped here, not tried it, but I wanted to show you that we can use either point. Okay, can I move on?
Yes.
All right, so we have one more thing. Well, actually, I'm going to teach you the second method tomorrow. But given something like this, okay, what makes this more challenging than the other graph? Jean. It doesn't give you a point. What else? Mason?
It's like in between 2 points.
Yeah, my y-intercept is in between. So we're going to take any intersection of 2 boxes, and we're going to choose that as a point. Doesn't matter which 2. Any 2. Now you could do one of 2 things. We know that we have a point which is, I don't know, I'm going to take 1, 1. You with me? That's an easy point. And now I could do one of 2 things. I could use the slope formula and find the slope, or we can do what? Rise. I'm rising -1, -2. And my run is 1, 2, 3. There we go. And now I'm using my point slope. Y minus y1 equals m times x minus x1. Y minus 1 equals -2/3 times x minus 1. Y minus 1 equals -2/3 x plus 2/3. I'm adding 1 or adding 3 over 3. And we end up with y equals -2/3 x plus 5/3. Yes?
On the test, do we have to write the equation, or could we just do the rise over run?
You could either use the slope formula. If I see these little kind of bubbles, I'll know you're doing rise over run.
Okay.
Okay. So let's see. I think that's it for today. Let me see what else we have. Shh. I haven't really been able to finish this. Okay. So I'm going to stop there. Okay. In your book, example 1 and 2 might show you something differently. I want you to use point slope. Here's my theory. There's always multiple ways to solve things. I like this method because I think there's the least amount of mistakes. The first method you use is usually the one you take to. So I want to teach you the formula that has the least amount of mistakes. Try not to go back to the book and read it. You can read example 3. That's point slope. Yeah.
What do you mean the formula can have mistakes?
Well, I'll show you a method, not a formula, a method. The other method for doing this, what happens is it's the method where we search for B, and then when you find it, kids tend to stop. I don't like that method because then you got to go back to the equation after you've done all the math and plug in your slope or substitute in your slope and your y-intercept, your B. So I want you trying to use this point slope tonight. Got it? Yeah. Okay. That's it.